So, let's go. Number 1, Proxima b. You are standing on the closest thing to a second Earth that exists. 4.25 light years from where you were born. A rock about the size of your home planet sits in the warm band around its star, exactly where liquid water is allowed to be. It is the nearest habitable zone world in the universe, as far as anyone can prove. If there is a first stop for the human species, this is it. The sun above you is Proxima Centauri, and it is small, deep red. It sits in the sky bloated and dim, and it does not move. It has not moved for 1 billion years. This planet is locked in place, one face turned to the fire forever, the other face turned to the dark forever, and you happen to be standing on the lit side. Then, on the 1st of May, 2019, that star does something. For 7 seconds, it gets 14,000 times brighter in ultraviolet. Not 14%, 14,000 times. 5 separate telescopes catch it at once, including Hubble, including a radio array in the Chilean desert that had never seen a stellar flare at millimeter wavelengths before, and now had one. The whole event is over in less time than it takes you to read this sentence, and it is roughly 100 times more violent than a large flare from our own sun. Now put yourself back on the surface for those 7 seconds. You would not see it as light. You would experience it as a dose. Ultraviolet and X-rays arriving all at once with nothing between you and them, because this planet's slow, locked rotation may mean it never spun up a proper magnetic field, which means there is no invisible shield doing what Earth's does for you every single second of your life without asking. Some researchers argue there might still be a liquid iron core down there generating something. Might. That word is carrying an entire civilization's worth of hope. And here's the part that should bother you. That flare was not special. It was just the one we happened to be watching. The star does this regularly. Whatever atmosphere this planet started with has been standing in that wind for 4 billion years. So we should go look. Obviously, we should go look. Voyager 1, the fastest thing we have ever thrown out of the solar system, would need about 73,000 years to get there. The most aggressive serious proposal on the table involves firing a laser at a sail the size of a bedsheet, and even that only takes 20 years. Only carries a chip the weight of a paperclip, and then you wait another 4 years for the pictures. 4 light years, the closest one. And we can send a paperclip. There are 9 more of these, and they get worse. Number 2, TRAPPIST-1e. You have heard of this one. 40 light years out, a tiny red star with 7 planets stacked around it so tightly that the entire system would fit comfortably inside the orbit of Mercury. 3 of them sit in the habitable zone. The middle one, the good one, is E. Stand on it. The first thing you notice is the sky is full of planets, not points of light, disks. Your neighbors hang up there, bigger than our moon looks from Earth, showing phases, showing surface detail, close enough that you could watch weather move across them if they have weather. It is the most spectacular sky in the known catalog. The second thing you notice is that everything is dim and red and nothing is moving. This star throws most of its energy out as infrared, which your eyes cannot see, so the light is thin and the color is wrong. Noon looks like a sunset that has stopped. Your shadow is long and it never shortens. We have spent enormous amounts of the most expensive telescope ever built staring at this exact planet, and here is what we know after all of it. We know it does not have a clear hydrogen atmosphere. That's it. That is the confident answer. Everything else is a shrug. A Venus-style atmosphere looks unlikely. A Mars-style one looks unlikely. A nitrogen atmosphere with traces of methane and carbon dioxide, which is to say something uncomfortably close to breathable, is still allowed by the data. So is bare, airless rock. Those 2 possibilities are both on the table at the same time, and the difference between them is the difference between a world and a gravestone. You want to know why? We cannot tell. The star keeps lying to us. When a planet crosses in front of its sun, you read the starlight that filters through the planet's air and you look for the fingerprints of gases in that light. It works beautifully. Unless the star has spots and bright patches on its face, in which case the planet moves across a surface that is not uniform, and the light changes for reasons that have nothing to do with the planet at all. It looks like atmosphere. It is not atmosphere. It is weather on the star. Every single observation of this system has that contamination in it. Everyone. There are papers arguing there might be methane in the air of TRAPPIST-1e, and the same papers spend paragraphs warning that it might just be star spots wearing a costume. 40 light-years is close in this business. We have pointed our best instrument at it for years. We still don't know if it has air. Number 3, LHS-1140b. Forget everything you picture when someone says habitable planet. No continents, no blue marble, no coastlines. This world is a single enormous eyeball, and it is staring at its sun. Here's what the data says. It is about 1 7/10 the size of Earth, and it is not dense enough to be solid rock. Something like 10 to 20% of the entire mass of this planet may be water. That is not an ocean sitting on top of a world. That is a world that is substantially made of water. It is tidally locked, so one hemisphere burns and one hemisphere freezes, and in the best current model, almost the whole planet is buried under ice. Almost. Directly beneath the star, where the light lands hardest and never leaves, the ice gives up. It melts open into a single circular sea about 4,000 kilometers across, sitting at a comfortable 20 degrees Celsius in the middle, ringed by a permanent wall of ice and a permanent collar of cloud where the warm water meets the frozen shore. One ocean. Round. Never moves. Always noon at its center. Always night at its edges. In July of 2024, Webb looked at this planet and found a hint of nitrogen. Nitrogen matters more than it sounds. Nitrogen means a real atmosphere with weight to it. The heavy kind of air that holds pressure down and lets liquid water stay liquid instead of boiling straight off into space. It is the difference between the eyeball and a dead frozen marble with no eye at all. It is the difference between a place and an object. The signal was tentative. The team said so immediately, in print, in the careful voice scientists use when they are excited and refuse to be caught being excited. It needs confirmation. It has not been confirmed. So walk the shoreline for a second. You are on the ring of ice at the edge of the only open water on an entire planet. Behind you, the ice goes on until the world curves away into permanent night. And it has never once thawed. In front of you is 4,000 kilometers of water that has never had a tide, because there is no moon to pull it and no rotation to swing it. The sun sits directly overhead, dim and red and nailed in place, and it will be directly overhead tomorrow, and in 10 million years. This is currently our best candidate. The most promising habitable world we have found anywhere, and we are not sure whether it has air, whether the ocean is real, or whether we are looking at a corpse with one open eye. Number 4. Ross, 128b. Every other planet on this list has the same fundamental problem. The star. Red dwarfs are violent, and habitable zone planets orbit them close, and being close to something violent is a bad long-term plan. Ross. 128 is quiet. That is the whole reason this planet matters. 11 light-years away, in Virgo, sits a red dwarf that mostly behaves itself. Low flare activity, calm, almost boring. And around it, discovered by a team out of Grenoble in July of 2017 and confirmed that November, is a rocky planet about 35% heavier than Earth, catching about 38% more starlight than you're getting right now. A temperate rock around a well-behaved star, 11 light-years out. On paper, it is one of the sanest things in the catalog. But that is not why you have heard of it. In the spring of 2017, the Arecibo dish in Puerto Rico picked up something coming from this star, a radio signal at a frequency nobody had ever seen a red dwarf produce. Strange enough that the astronomers who found it did not have a category for it, and strange enough that when word got out, the internet did what the internet does. They called it the weird signal, with an exclamation mark. That is the actual name they used because they genuinely did not know what else to call it. For a few weeks in 2017, our real research team was seriously working through the possibility that something 11 light-years away was making noise on purpose. It was our own satellites. Geosynchronous transmitters, ours, in orbit around this planet, bouncing their signal into the telescope while it happened to be pointed at a star. The universe had not spoken, and then we had failed to recognize our own voice coming back. Sit with that one, because it is the cheapest and most human failure on this entire list. Every hazard we have covered so far is physics being indifferent to you. This one is us. We built the noise. We pointed the instrument. And we spent weeks wondering if we were alone. The planet is still there. It is still one of the better candidates we have. The star is still quiet. And the only signal we have ever received from that direction was a message we sent to ourselves. Number 5. Teegarden B. 12 light years away, there is a star so old it makes our sun look like a toddler. Teegarden star is roughly 8 billion years old. Ours is 4.5. That is 3.5 billion extra years of just existing quietly, while nothing much happened here. And the planet closest to it in the habitable zone, Teegarden B, catches somewhere between 106 and 123% of the light Earth gets. Right in the window. Not too much, not too little. When it was announced in 2019, it took the record. Highest Earth similarity index of any planet ever found. That number is a composite score built from size, density, gravity, and temperature. And Earth scores a perfect 1.0 by definition because we made the scale out of ourselves. Teegarden B came in higher than anything else on the board. In February of 2024, someone went back and redid the measurements. The score dropped to 0.9. Record gone. The most Earth-like planet ever discovered stopped being the most Earth-like planet ever discovered, not because anything about the planet changed, but because we looked more carefully. Here is the number that actually matters, though, and it is the ugliest number in this video. Best estimates give this planet roughly a 60% chance of having liquid water on its surface, and roughly a 3% chance of having an atmosphere at all. Read those two together. 60% and 3%. A planet the right size at the right temperature, catching the right amount of light. That has almost certainly been stripped naked by its own star. That gap between those two numbers is the entire tragedy of red dwarf real estate written out in 2 figures. Now do the thing that actually ruins your night. Red dwarfs do not burn out. They are so miserly with their fuel that they will still be shining trillions of years from now, long after every sun-like star in the galaxy has died and gone cold. Which means that planet around that 8 billion-year-old star has had a head start on Earth of 3.5 billion years, with a window ahead of it so long the number stops meaning anything. 3.5 billion years of extra time, and nothing has ever called. Number 6, TOI 700E. This is the one with nothing wrong with it. In January of 2023, a team at NASA confirmed it working from test data. 95% the radius of Earth. About 8/10 of Earth's mass. It goes around its star every 27.8 days, which means its entire year is shorter than one of your months, and it sits in the habitable zone of a calm, well-behaved little star that is not trying to strip it. And it is not even alone. There's another Earth-sized planet in the habitable zone of that same system. 2 of them, in one place, around one quiet star. That combination is close to unique in everything we have surveyed. No superflares to talk about, no contamination problem making the data useless, no eyeball geometry, no 3% atmosphere odds, no embarrassing signal we accidentally sent ourselves. Just a small rocky world at a reasonable temperature around a star that leaves it alone. So here's where this video stops being about danger. Because every planet before this one had a villain. The flare. The star spots. The ice. The silence. You could tell yourself a story where the problem was a specific planet and somewhere out there is a better one. And if we just keep looking, we'll find the good one and go. This is the good one. It is 100 light years away. There is no spacecraft built or drawn or seriously funded that gets a human being anywhere near it. Not this century. Not this millennium. The laser sail concept that might reach the nearest star in 20 years is aimed at something 4 light years out, and it carries a chip, multiply that distance by 25, and then try to put a person on the end of it with food, with air, with a way to stop. The barrier was never the flares. The flares are just what we talk about because they make a better story than the truth. The truth is that the good ones are out of reach, and being out of reach is permanent in a way that hazards are not. A hazard can be engineered around. 100 light years cannot. And every single time we get a clear answer back from one of these worlds, the answer narrows. How strange and specific and lucky the setup under your feet actually is. Number 7, Wolf, 1069. B. 31 light years away, announced on the 3rd of February 2023, there is a planet with the same mass as Earth and roughly the same size as Earth sitting in the habitable zone of a small red star. Half of it has never been lit. Not once. Not for a single second in the entire history of the planet. It is tidally locked like almost everything on this list, which means the star is nailed to one spot in the sky on the day side and has never risen at all on the other. There is no sunrise on this world. There has never been a sunrise on this world. There is no dawn, no dusk, no noon, no evening, none of the words your species built its entire sense of time out of. Stand on the day side, the star sits wherever it sits, and it stays there. Your shadow points one direction, and it will point that direction for the rest of your life. And for the rest of everything after your life. Nothing that lives there would ever have evolved a body clock, because there would be nothing for the clock to track. Now walk toward the edge. The light gets lower and redder and flatter as you go. The shadows stretch out longer and longer, and eventually you are standing in a permanent band of twilight that circles the entire planet, a ring of endless almost evening. Past that ring, it is dark. Not night, because night implies morning. Just dark, and it is the same dark that has been there since the planet formed. And on the far side, if the atmosphere is thin, something quietly horrifying happens. The air freezes. On a locked world without enough atmosphere to circulate heat, the gas drifts to the cold side, touches ground that has been in shadow for 4 billion years, and stops being gas. It falls out of the sky as ice, and it stays. The planet slowly breathes itself out onto its own dark hemisphere and never breathes back in. It suffocates by geometry. The team that found this one is optimistic. Their models suggest that with a decent atmosphere, a wide band of the day side could stay genuinely comfortable. Water, stable temperatures, a place where you could stand outside. You just have to stand there under a sun that never moves, on the lit half of a world whose other half is a 4 billion-year-old ice cellar full of frozen sky. Number 8, Kepler 1649c. 301 light-years away, in Cygnus, is the closest match to Earth that the Kepler telescope ever produced. 1.06 times our radius, almost exactly our size. Catching about 75% of the light we get, which puts it comfortably in the range where the water stays liquid. Of all the thousands of planets that mission found, this is the one that lines up with us on both size and temperature at the same time. Kepler found it years before anyone knew it existed, because the software threw it out. Kepler generated more signals than any human could ever look at by hand, so the mission ran automated vetting to sort the real planets from the noise, and that pipeline looked at this particular signal and labeled it a false positive. Not a planet. Junk. Filed in the discard pile with tens of thousands of other rejects and left there. In 2020, a group of researchers went back through the garbage. That is genuinely the story. A team went through the signals the algorithm had already dismissed by hand, looking for anything the machine had gotten wrong. And on the 15th of April, they announced that the most Earth-like planet Kepler ever found had been sitting in the rejects the entire time. Think about what that implies for a second, because this is the part nobody says out loud. That planet is not special. It was in the discard pile, with everything else in the discard pile. Nobody has gone through all of it. Nobody is going to go through all of it. The catalog of habitable worlds you see quoted in headlines is not a list of what exists. It is a list of what survived automated filtering, and we have direct proof that the filter deletes exactly the kind of planet we most want to find. There are almost certainly more of these, sitting in archived data, already collected, already paid for, already thrown away. As for the planet itself, it circles a red dwarf every 19.5 days. Nobody has caught that star flaring yet. Nobody has been watching it very long either. Number 9. Kepler 442b. In 2015, a group of scientists built a mathematical index to rank how suitable a planet is for life, ran it across everything in the catalog, and one planet came out above Earth. 0.836, Earth scored 0.829. You can imagine how that traveled. A planet more habitable than Earth. Better than home. Scientists find a world that beats our own. It has been in headlines and thumbnails and comment sections continuously for over a decade, and it is one of the most repeated facts about exoplanets in existence. The people who built the index put a line in their own paper explaining that a score higher than Earth's does not mean the planet is more habitable than Earth. It is right there. In the paper, in the same document that produced the number, everybody quotes. The index measures a narrow thing, roughly how favorable a planet's orbit and energy budget are for keeping liquid water around, given some assumptions. It does not know whether the planet has an atmosphere. It does not know whether it has water. It does not know whether the surface is rock or magma or nothing at all. It is a score for the parking space, not the house. The planet is real, and it is a genuinely good candidate. Rocky, about 1,120 light-years away, catching around 70% of the sunlight that warms our oceans. If you were making a list of places worth pointing a very large telescope at, it is on the list. But look at what happened. We generated a number, the number was correct. The meaning everybody extracted from the number was wrong, and the correction was printed in advance, in the same paper, and nobody read it, and the distance, since you are wondering, 1,120 light-years. At the speed of the fastest object we have ever launched, that is roughly 19 million years of travel. Your species is about 300,000 years old. You would need to do everything humans have ever done, from the first stone tool to right now, more than 60 times over, and you would still be in transit. That is the planet we decided was better than home. Number 10. Kepler 452b. On the 23rd of July 2015, NASA announced they had found Earth's older cousin, 1,400 light-years away, a planet about 1 6/10 the size of our own, going around a star that is not a red dwarf. Not a dim little ember, a genuine sun-like star, the same temperature as ours, and the planet sits in its habitable zone, taking 385 days to complete an orbit. A year. An actual, recognizable year. Everything else on this list orbits something small and red and hostile. This one orbits a sun, and that star is 6 billion years old. Ours is 4.5. You are looking at your own solar system, running 1.5 billion years ahead of schedule. Here's what that means, and it is the reason this planet closes the video. Stars do not stay the same. As they age, they brighten. Ours has been slowly getting hotter for its entire life, and it will keep going. And eventually the extra energy will be enough to push Earth past the line where oceans stay oceans. Water evaporates. Water vapor traps more heat. More heat evaporates more water. The loop closes and it does not open again, and the planet cooks itself in its own steam. That is a runaway greenhouse, and it is the reason Venus looks the way it does. Kepler 452b's sun is 20% brighter than ours and 10% wider, and it is doing that to its planet right now. A scientist on the Discovery team put it plainly, the increasing energy from its aging sun might be heating the surface and evaporating any oceans. So picture it. Twice the gravity of Earth, so every step costs double. A sky going white and thick with steam. Whatever water is left retreating into shrinking patches under a sun that is not going to stop getting brighter on a world that had 1.5 billion years more than yours to build something worth losing. The man who led the discovery said we can think of it as an older, bigger cousin to Earth, and an opportunity to reflect on our own planet's evolving environment. That is an extremely polite way to describe watching your house burn down from 1,400 years away, because the light showing you that steam left there while the Roman Empire was collapsing, it has been crossing the dark this entire time, through everything your species has ever built and forgotten, just to arrive here and show you the ending. We went looking for somewhere to go. Every world we found is either trying to kill us, lying to our instruments, or so far away that reaching it would take longer than we have existed. And the one that looks most like home turned out not to be a destination at all. It is a mirror running slightly ahead of us, and it is on fire.